Welcome. Today we're talking about operational technology, or OT, and industrial control systems, ICS. These run our power grids, water plants, factories, the backbone of industry and critical infrastructure. Once isolated, they're now connected to IT networks and the internet. This boosts efficiency but creates huge cyber risks. Unlike IT security focused on data confidentiality, OT security prioritizes safety and availability because breaches can cause real-world physical harm, impacting operations, the environment, and even lives. The 2025 OT threat landscape is escalating. Ransomware hits industry hard, especially manufacturing, often via supply chain weaknesses. More organizations report intrusions impacting OT, with attackers exploiting weak perimeters, old legacy systems, and vulnerable remote access like standard VPNs. Nation-states target critical infrastructure, like energy and water, for geopolitical reasons, aiming for disruption now or later. They often pivot from compromised IT networks into OT. Plus, the boom in industrial IoT devices adds billions of potential, unsecured entry points. Securing OT presents unique challenges. Many systems are legacy, old hardware and software not built for connectivity, hard or impossible to patch without risking downtime. Integrating IT and OT blurs network lines and expands the attack surface. IT security focuses on confidentiality. OT needs safety and uptime, so IT tools often can't just be dropped in. Gaining full visibility is hard. OT environments are complex, dispersed, using varied equipment. It's tough to inventory everything, leaving vulnerabilities hidden. There's also a skills gap, a shortage of people expert in both OT processes and cybersecurity. Lastly, increased connectivity via remote access, cloud, and IoT, while useful, introduces significant risks. So, what's the strategy? First, a comprehensive asset inventory. You can't protect what you don't know. Second, risk-based vulnerability management. Prioritize patching critical flaws, especially known exploited vulnerabilities, and use mitigation when patching isn't feasible. Third, network segmentation. Isolate OT from IT and segment within OT using models like Purdue and OT-specific firewalls to contain breaches. Fourth, secure access control. Enforce least privilege. Use multi-factor authentication, especially for remote access, and implement OT-specific secure remote solutions, moving beyond just IT VPNs. Manage passwords properly. Fifth, continuous monitoring with OT-aware tools like SIEM and IDS to spot anomalies quickly. AI can enhance this. Sixth, have a tested OT-specific incident response plan ready. Seventh, physical security is still vital. Lock down sensitive areas. Eighth, rigorous supply chain security. Check your vendors. Ninth, train both IT and OT personnel on risks and best practices and encourage collaboration. 10th, stay compliant with regulations and standards like NIS2 and ISA IEC 62443. Looking ahead, expect more AI for threat detection, shifts towards zero-trust architecture, and stricter regulations. Protecting these vital systems demands ongoing investment, a proactive stance, and a holistic strategy combining technology, process, and people to ensure safety, reliability, and resilience.